So coming into this project, I really wanted to find an internship on chemical engineering because that's what I plan on majoring in college. And I thought this experience would be good to get some hands-on experience and figure out if I actually like the topic. So I got in contact with a lot of different places like Merkup and Harrisonburg. Unfortunately, they weren't necessarily looking for a job shadow internship, more of a co-op internship, and especially if I was a college student and had the background information, and I don't, so I wasn't able to obtain an internship with them. But I was referred to a biomedical engineer professor at UVA, Dr. Jason Pappin. And not only is he a professor at UVA, but he's also the head of a graduate and undergraduate research program dealing with computational systems biology. And this program is really unique because each of the grad students gets to choose their own topic and manipulate their experiments however they like. And Dr. Jason Pappin is more of a mentor in that, kind of just giving advice and overseeing their projects, which is really cool to see everyone working together like that. So my internship was hosted at the Claude Moore Medical Education Building in UVA. And here is where Dr. Pappin's lab is, as well as the graduate student's lab and his office. In my first day, I toured the labs. I got to see the graduate student's lab mainly because there's nothing really going on in Dr. Pappin's lab at the moment. And so I got to see all their experiments kind of laid out. And one area had bacteria growing in petri dishes, and another over here. And it was fun. It was really cool to see all of them laid out like that. And after going on lab tours, I attended lab meetings, and this was once a week, every Wednesday. And at lab meetings, the graduate students get together and they discuss their experiments and what's kind of going on. And each week, about 2 to 3 grad students put together a slide presentation that includes graphs, charts, and pictures to kind of get the other students aware of what their experiment is about, and if they had any feedback on it to help kind of work together, and if they had any questions themselves, then they could ask them then. So I attended a couple of those, and I also attended Dr. Pappin's lectures that were for all of his engineering students. I attended 2 lectures. One was biology-based, which was dealing with gene therapy and gene replication, and one was dealing mainly with the computer side and programming and all that stuff. So it was cool to kind of separate computational systems biology into 2 separate courses, and then seeing them all together in this program. So these are 2 graduate students that I worked with, Tom and Amanda. Tom's experiment was the most interesting to me because he had manipulated E. coli so that it had purposely become antibiotic resistant, solely for the purpose to find a way to treat antibiotic resistant E. coli. And so I thought that was interesting because he didn't necessarily have a solution for this awful pathogen, but he created this mutant pathogen just to find research on it, which I thought was really interesting. So for my community service, I worked with the American Heart Association, and I got in contact with Miss Tori Sancho-Bonet, who is the head of events director in Charlottesville, and I mainly worked with her through the Heart Walk that was hosted in Boar's Head back in November. And at this Heart Walk, I was assigned a booth, and the way that it was laid out is that we had about 20 booths in an open field at Boar's Head, and it was like an hour and a half, and it was kind of like an informational session. Some booths had flyers of like how to eat right, how to spot a stroke, and how to prevent heart disease all together. And at my booth, I handed out hats for promotional reasons, and I also collected information on heart disease survivors that wanted to share their stories with others at other Heart Association events. And after that little information session, we went on a walk that was about 3 miles, and that was for raising money for the organization itself to further their research on how to find a cure for heart disease. And I was lucky enough that 3 of my fellow students decided to come and support me that day. It was really nice of them. So for my legacy portion, I decided to have the American Heart Association come to the high school and sponsor a home basketball game. And I emailed Miss Sancho-Bonet if she was able to come down and kind of have a booth like we did at Boar's Head. Unfortunately, she couldn't come, but she had referred me to another associate there, Miss Amy. And Miss Amy and I set up a booth outside of the gymnasium. And at our booth, it was kind of like a mini version of what happened at Boar's Head. We had flyers of how to eat right and how to prevent heart disease and how to spot a stroke. And we also collected money to donate our proceeds to the organization to help further their research. So for my research question, I wanted to take a positive spin on bacteria because you hear that bacteria is terrible and makes you sick and all these things. So I wanted to see if there were any benefits of genetically engineering bacteria. And I found a lot of case studies dealing with this topic. For example, one of them was done by a professor at Nanyang Technical University, and she had manipulated E. coli so that it can sense and eradicate the pathogen Pseudomonas aeruginosa. Pseudomonas aeruginosa is naturally antibiotic resistant, and she chose this pathogen because her overall thesis question was trying to figure out a way to fight against antibiotic resistant pathogens. And so how her experiment worked is she injected a host with Pseudomonas aeruginosa and then also injected it with the E. coli. And once the E. coli sensed the pathogen in the environment, it was then programmed to release a toxic protein called pyosin that would tell the pathogen to self-destruct, and it was eliminated from 99% of all viable cells in the host, which was a very successful trial. And my other case study that I researched was done by Dr. Hodgins, who is president of Global Chem. And in his research, it was similar to the previous one, but he used a different form of bacteria. He used a virus, which is a bacteriophage, which is pictured up here. And they're different from bacteria solely on the way they replicate. How a bacteriophage works is that they have DNA stored up in the head up here, and when it is when it's in the body, it will latch itself onto a cell, a healthy cell, and inject its own DNA into the cell. So then that tells the cell to produce more and more of these bacteriophages. And once the cell gets filled with all these viruses, it will release them into the body, and that's how we get more and more sick. But in Dr. Hodgins' case study, he removed the bacteria, the original bacteria in the, DNA in the bacteriophage, and inserted DNA that was coded to produce antigens instead of antibodies, or antibodies instead of antigens. So he had gotten his test subjects were mice, and he infected them with Pseudomonas aeruginosa, like the previous experiment, because he was also trying to figure out a way to fight against antibiotic-resistant pathogens. And so once he had the mice sick enough, that he also then injected them with this modified bacteriophage. And it was a successful trial, and all the test subjects were well again, and none of them had died from it. And so that's just another example of modified bacteria and providing benefits to the host. And so for an overall solution to my research question are genetically engineered vaccines. And they're different from today's vaccines because in today's vaccines, you have a dead or very weak strain of whatever virus or pathogen you're trying to fight against. And so when we're injected with that, like the flu virus or the flu shot, we get a little bit of the flu virus in us so the body can recognize the pathogen and start building up antibodies. But engineered vaccines work differently because they actually have bacteria in them to produce the antibodies for our cells. So, for example, the E. coli back in that case study would be in this vaccine programmed to create antibodies, say, for the flu virus or whatever virus you're trying to prevent against. And so they're non-pathogenic, so they won't get us sick, and they're extremely effective in fighting against pathogens. The only problem is that they're really expensive to manufacture because they have to go through so many phases in the FDA approval process. So that's why they're not in circulation today, but they are certainly working towards having them in or available for the public. So throughout this internship, I definitely learned a lot about myself academically. I didn't realize that I was so interested in biology because I had my mindset in chemistry and chemical engineering. So I didn't really think about biology. But when I was able to attend lectures and talk to these grad students about their experiments, I really enjoyed the biology aspect of biomedical engineering. And a piece of advice for next year's seniors, I would say don't wait on getting in contact with people. You can start doing that over the summer or in the end of junior year. Just because once you come in the doors first day, everything's so chaotic with, first day school, getting all your classes ready, figuring out what colleges you want to apply to. And so having that already done kind of gets you ahead of the game, and you won't have to worry about it throughout the first couple months that you're there. And as of right now, I plan on attending Virginia Tech, and I'm still going to major in chemical engineering, but they also offer a minor in biomedical engineering, so I'm hopefully going to minor in biomedical engineering as well.
Thank you. Any questions?
So with your engineered vaccines that you propose as a solution, with the bacteria coming in and producing the antibodies for us instead of us producing them, would there be like a time limit on how long it's effective? Traditional vaccines, it train our own immune system, and then that memory stays forever. But this one's just bacteria. Would they stay in us and be able to always set that off, or would it just kind of...
That didn't come in my research, but I would assume that since the bacteria is in the body creating the antibodies, your immune system will recognize the antibodies and latch onto that and start making their own without having to be exposed to the virus itself.
Yes.
What surprised you most in the lab? Is there anything that surprised you?
It's kind of a standard lab, but what surprised me was what Dr. Pappen had said, because I had walked in and he was telling me all these experiments that were going on, and he was like, oh, this bacteria could, kill you, and I was like, oh, that's lovely. But he was saying that the only thing I really had to worry about was the bacteria that was on the door handle, like not anything that would come out. So I thought that was really kind of cool to see that. I was like, okay, I'm inches away from something that could kill me, but it's okay. So I thought that was really funny. Yes.
Was there any discussion about how these new vaccines may be perceived by the public? There's already sort of a negative sort of view by some about vaccines, and then bacteria on top of that.
There wasn't really a study out about that yet because they hadn't been in circulation, but I would assume that they would just have to release a lot of research about it, because a lot of people would assume, well, if I'm going to be injected with E. coli, will I get, that bacteria? But they don't understand that the DNA from E. coli itself isn't going to be in you, so that's not going to affect you.
So what is the connection between your internship and your service?
Well, I had connected it by the American Heart Association doing their own research on how to cure a disease that has yet to be found, much like the antibiotic-resistant pathogens that a lot of the grad students were looking towards to and researching against. So I kind of put those two together, and saying that they both are doing research on something and fighting against pathogens that, or diseases that haven't yet been